Okay, this was just the last example on today's notes, and some people had asked for clarification or to see my steps on how I found A inverse, the matrix. So just remember that what we had done is we had set up a matrix equation. We had our coefficient matrix, and it was being multiplied times the variable matrix, and it was equal to the constant matrix. And remember that what we were trying to do is we were trying to solve a matrix equation that looks like this. Okay, and remember we can't divide both sides by A to get rid of A, so what we're looking to do is we're looking to multiply both sides by A inverse. And so that's what we're doing. Here's our A. We need to find A inverse to put it out in front. So I had asked you guys to jump off to the side and find A inverse for yourselves. And that's where people were getting stuck. So I want to remind you guys that you have two options. I'm going to flip to the next screen. And your two options were, when you're trying to find the inverse of this, 2, 3, 1, 4. Option 1 was to take that matrix, which is what we're calling A, and set it up in a new equation. And what it would look like is this, 2, 3, 1, 4, there's matrix A. If we knew what its inverse was, it would be A, B, C, D. And when the two matrices multiply together, they'll be equal to the identity matrix. So that was option 1. Option 1 was to physically multiply these two matrices together, and what that would do is generate two systems of equations for you to solve, and you would solve for A, B, C, and D. From what I saw, the majority of people who were doing this problem were using the second method. And the second method was to use an augmented matrix. And so that means we take matrix A, which is this, put it on the left side of the augment, put the identity matrix on the right side of the augment. And now our goal is to take this left side, put it into reduced row echelon form, and whatever remains on the right side is our answer. And in this case, our answer is going to be A inverse when we've found it. Okay, it's not A inverse yet, but it will be. So if I want this left side to be put into reduced row echelon form, my first goal is to make this become a 0. So in order to do that, I'm going to take row 1 and I'm going to subtract 2 times row 2. The answer that I get, I'm going to use to replace row 2, because that's what's going to make this become a 0. Okay, so since this tells me I'm replacing row 2, I'm going to leave row 1 exactly as it is, so I copy it just the way it was, and then I can perform the operation. So row 1 minus 2 times this, so 2 minus 2 gives me the 0 I'm looking for. This minus 2 times this, so 3 minus 8 gives me negative 5. This minus 2 times this, so 1 minus 0, still 1. And 0 minus 2 times this gives me negative 2. Okay. Then the next thing that I need to do is, I've got the 0 here for reduced row echelon form, right there. I need this now to become a 1. So the next step is to take row 2, multiply the whole thing through by negative 1/5, and that will become my new row 2. Okay, so once again, I'm leaving row 1 exactly as it is, and row 2 I'm simply going to apply a scale factor. The 0 is going to stay a 0, This is going to become a positive 1. This becomes negative 1/5. And then this becomes positive 2/5. Okay, so the bottom row is now giving us 2 of the 4 terms of the inverse matrix we're looking for. Okay, so the bottom row is done. So now the next step is to make this become 0. Okay, so in order to do that, I'm going to take row 1, and this time I'm going to subtract 3 times row 2, but the other thing that's going to change is I'm going to use that answer to replace row 1 this time instead of row 2. So I know I'm running out of space. I'm just going to try and get this next step on this page, and then I can erase at the top, or I can move to the next page. But this time I'm replacing row 1, so row 2 is going to stay exactly as it is. Now remember, in class I wrote these fractions as decimals, so I'm going to go ahead and do that. I'm going to write this as negative 0.2 and positive 0.4 because they are nice, pretty, concise decimals, so I just think they look smaller and prettier. Okay, and so now I'm ready to perform the operation to row 1. So let me change colors again. So I'm going to take row 1, subtract 3 times row 2. So 2 minus 0, still 2. Okay, 3, so that's row 1, minus 3 times row 2. So 3 minus 3 gives me the 0 I'm looking for. This is a 1, and I'm going to subtract 3 times this. So the first thing that's going to happen is it's going to become addition, and it's going to become 3/5. So 1 plus 3/5 gives me 8/5, which once again, if you want to write it as a decimal now, that's fine. That would just be, what, 1.6. And then this one, row 1 minus 3 times row 2, so 0 minus 6/5. Is minus 6/5. Okay, and then your final step, I guess I'm going to go ahead and jump up here to the top because I don't want to have to flip back and forth between the pages. So the final step is to take row 1 and reduce it, apply a scale factor to it. So I'm going to do half of row 1 and use it to replace row 1. And I'll be done, because this will become a 1 and a 0. Half of 8/5 is 4/5, which once again I'm going to go ahead and convert to a decimal now because it's my final answer. Negative 6/5, going to chop it in half, becomes negative 3/5. So negative 0.6. And then I didn't do anything to row 2. So the left side became reduced row echelon form for matrix A, and what's left on the right side is my solution. In this case, my solution that I was looking for is A inverse. Okay, so there's A inverse. Now I'm going to go ahead and I'm going to finish solving that system that we were solving. So if you had already wrapped up at the end of the period and need to see this again, or in 7th period if you're going to be absent on Friday because we hadn't finished this problem, feel free to continue the video. If this is the only part of it you wanted to see, go ahead and stop now. Okay, so the next step, I'm going to take my original matrix equation, which was 2, 3, 1, 4 times the variable matrix, and I'm going to go ahead and I'm going to leave some space because I already know what I'm going to do, and it was equal to the constant matrix. Okay, and I'm now going to multiply by A inverse, but I have to place it in the correct location. This is A. I can't cram A inverse back here because matrices would need to be multiplied in order, and A inverse isn't going to cancel A then. So I'm going to put A inverse out here to the left of A. And A inverse that we just found was 0.8, negative 0.6, and negative 0.2, positive 0.4. And since I've placed it to the left to multiply on the left side of the equation, I also have to place it to the left. Wait, no, it's positive 0.8. So 0.8, negative 0.6, negative 0.2, positive 0.4. So I also have to place it to the left on the right side of the equation. Now, remember that you need to be prepared to do this, but we didn't do it in class. I'm not going to make you do it right now. We know that since these two are inverses of each other, they're going to cancel each other out. They're going to become the identity matrix. We also know that any matrix times the identity matrix is going to leave the matrix alone, or the same. And so that means that just telling us what XY, it's isolated the variable matrix. Okay, and then the last thing is what's going to result on the right side. Now remember, once again, I'm going to kind of go off on a little tangent. Remember matrix multiplication. The first thing is, how is it that we know that those two matrices will multiply? We have a 2 by 2 being multiplied to a 2 by 1. Those two inner dimensions match. That tells us that they can be multiplied. The outer dimensions tell us the dimensions of our answer matrix. So when I'm doing the multiplying, usually what I will do is I will set up a matrix with a nice sizable chunk of space to do the arithmetic, and then I'll have a much more concise final answer matrix. When I want to find this term right here, this is term 1, 1, first row, first column. So that means I'm going to take the first row, multiply it times the first and only column. And I'm going to multiply the corresponding terms. So first term times first term, second term times second term, and then add them together. So when I do first term times first term, 0.8 times 7 is 5.6, plus, then when I do second term times second term, I get a negative 3.6. Well, that means it results in subtraction, and 5.6 minus 3.6 is 2. And then this is entry 2, 1, because it's the second row of the first column, and that tells me to multiply the second row times the first column using the same process. So first term times first term gives me negative 1.4, plus second term times second term gives me positive 2.4, and the result is positive 1. So there's our solution matrix. And so that tells us that the solution to our system is the point 2, 1. That's what it tells us. Okay, so now you can practice it. This was the conclusion of the 6.4 notes. And now you can try the 6.4 homework, and then you can get help in class if needed. Thanks.